exponential decay, half-life. Use this exponential model to solve this problem. A naught represents the initial amount, K is the rate, T is the time in hours, and A is the amount after T hours. The half-life of aspirin in your bloodstream is 12 hours. So the half-life. So initially, you have 100%. 12 hours later, you have half of 100%. So that means we have an amount. And then we keep reducing this amount by half. Are we going to reach to 0? The answer is no. So you can pick any numbers in your calculator, like a 10, a 15, or a 25. You just keep dividing that number by 2. You will never reach to 0. So you can do this, like you can divide that number by 2 like 27 times, but the quotient is getting smaller and smaller, but never equals to 0. So that is the concept of half-life. What is the question asking? The first question is asking how long will it take for the aspirin to decay to 70% of the original dosage. So 12 hours later, you have 50% left, but since they are asking for 70%, that should be less than 12 hours. So let's do some given. So the given is, so the half-life, what is this? So that is equals to 12 hours. And then that means when T is equals to 12, the initial amount is 100%, which is 1, and the current amount is 50%, which is equals to 0.5. Why are we doing this? Because we will need this to find the rate. Do you see what the exponential model? There is no rate. Okay, so 0.50 equals to 1 e to the kt. We don't know k. T is 12. 50 divided by 0.50 divided by 1 is still 0.50. So we have 0.50 equals to e to the 12k. And then I take the ln on both sides. So ln the left hand side and then ln the right hand side. Okay, the next step is, so we have ln 0.5 equals to, bring the exponent down, so 12k, and then multiply lne. Lne is equals to 1, and then the rate is equals to ln 0.50. Remember, you close the parenthesis when you do the computation in your calculator, divided by 12. And then k is approximately equals to negative 0.058. So that is my rate. Since that is a less than 0, the k is less than 0, so this is called a decay rate. So the model is exponential decay model. The amount of aspirin is decreasing because the rate is negative. And then what is the model for this problem? The model is you have A equals to, the initial amount is 1, and then e to the negative 0.058 times t. This is the exponential decay model for aspirin. If you give me something else like aspirin 2, aspirin 5, then that is another decay rate. So this is for the aspirin described in this problem only. So that is my model. Usually I box this because I will have to use this model a few times to answer some questions. The first question is asking, so now we are officially solving the first question. They are asking how long will it take for the aspirin to decay to 70%. So that will be the current amount is 70%. So for part A, 0.70 equals to 1 e to the negative 0.058 times t. You have to tell me the time, right? Then solve for t. Divide both sides by 1. Nothing changes. And then you ln both sides. So ln the left, and then you ln the right to bring the exponent down. Then this is ln 0.70. So 0.70 equals to, let's use parentheses, negative 0.058 t, and then multiply lne. What is lne? Lne is equals to 1. And then the time is, you have ln 0.70 divided by negative 0.058. So what is that equal to? When you do this in your calculator, remember, close the parenthesis for ln before you divide the negative 0.058, and you only approximate one time. to avoid the round-off errors. This one I got 6.1 hours, so 6.1 hours for question A. So it will take 6.1 hours to decay to 70%. And then B is to estimate the amount. They gave you a time, then you just plug in the time to the model. Okay, so for part B, they said that the time is equals to 20. Then easy, you just plug in. Then the current amount is 1 times e to the negative 0.058 times 20. So that one I have approximately equals to 0.3135. So that will be 31.35% after 20 hours. Okay, so that is the end of this problem. If you think my instruction is helpful, thumbs up, subscribe for more contents like this, and I will meet you all in the next one. Signing out.